I might have to drop it though, just because.
So just
I'm joking.
real quick, do you guys remember what a function is? I don't need a fancy definition. Can you just kind of give me an idea of what your understanding of it is? That's good. That's the notation you're thinking of. So you're thinking of when I hear you say f of x, you're thinking of function notation. So just remember, and you don't need to recite this. You don't even need to write this down. A function is a relation in which there is exactly one output for every input.
Yeah.
And you've heard that come out of my mouth before. You've probably put it on a test before. The idea is that in order to be a function, and this will become pretty important for us going into the next unit, the idea behind being a function is that you're a machine, essentially an equation, where for every time you put in an x, you will never get multiple y's to come out of it.
Mhm.
The moment you write an equation where like Zane walks up and puts in a number for X and then he plugs it in and boop, 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 it gives him back like a five. And then Zach goes in, both good mathematicians, and he puts in the same thing and it gives him a different number. You're no longer working with what's called a function, right? And so the purpose of today was really just to kind of get you behind the idea of how do we see that visually on a graph? So, do you remember what we do to a graph to determine whether or not it's a function? Does this come back to you from your past? If I put a graph like this, is that a function? It is not. I see you shaking your head. And the reason why you would say no, it's not a function is because it fails the vertical line test. And you'll remember that back in the day, we talked about the vertical line test. It's like a scanner. And what it really does, especially now that you're older, it'll even make more and more sense second time through, is that you see what's happening is that in this machine, one person, so here's an input of, we'll say like -3. I'm sorry, my line's not vertical. They changed their software and I can't get it. I'll figure it out. Anyways, one person puts in -3 and the machine returns an output value of like 3.2. The next person goes and puts in the same input of -3 and gets an output value of like negative, whatever that is, 5 point something. That right there illustratively is why this is not a function, is because you can see from the vertical line test when a machine is returning multiple y values for the same given x, right? So that's the thing we use. It's called the vertical line test. And again, it's just I saw you do this with your hand. I'm flattered that you remember that. And you just essentially scan it like a laser, like a stud finder. You just scan it across your graph. And if it hits the graph twice, it's not a function. If it never hits the graph twice, then it's a function, right? So yeah, it's a really hot sort of conversation. And we'll take it next level in this unit. Like we start kind of, we're going to have questions like, how do you restrict the domain of a given function so that when you invert it, its inverse is also a function, stuff like that. So it's imperative that you have like a really intimate understanding of what we're talking about when we talk about a function. So let's talk about domain and range. Who remembers what the domain, by the way, this is not a function. We would agree. So like if you're doing today's assignment, you'd say not a function. Boom, done, right? Who remembers what the domain is?
It's the X value.
Yeah, it's basically what X values get covered by you. That's a simple, plain English way of saying what domain is. Domain is Xness. And so if you think about this graph begins its existence essentially right here,
Yeah, and goes to infinity.
and it goes to infinity. So we would say that the domain of this graph, and we would write it as an interval, is this graph begins its journey. Do you remember all this?
Yeah.
At -1, 2, 3, 4, 5, 6. And then we put a comma and it ends its journey at positive infinity and it's a round. Infinities, whether they're vertical range infinities or horizontal domain infinities, will always get round. And why do we put a round? Like, what's the differentiator? What's the difference between square? Square is inclusive. Get used to that. Inclusive meaning like it's there. It makes it to there. The round means you can't get there. Right. And you'll see different representations of that. Sometimes you'll remember the little open circles represent exclusivity, and the little colored in circles represent inclusivity. Right. And then what would the range on this relation? I can't call it a function. What would the range be? How it's all wise, right? How we agree the graph will go forever to the low, so it's going to go negative infinity, and we would agree that the graph goes forever to the up. So this is one of those unlimited ones, right? So just maybe just, I don't know, one more. If you'll have some questions as you go, you can just ask. But again, this is all going to come flooding back to you. So say I gave you like this, like this. Got it? So first off, is it a function? Yeah, you would have no reason to say no. You could scan a vertical line through this all day and it's never going to hit the graph twice at the same time. So yes, it's a function. What is his domain? It starts horizontally at this line right here. Would you agree that that's where its existence comes into play? So that is at negative 1, 2, 3, 4. What kind of notation?
Wait, no,
Because it's an open circle, I want to say that that doesn't count. And so I'm going to use an open like this. We call these open and closed. And that's at negative 4. And how far to the right does it go? To positive infinity. And again, that's hard for some people. We talked about this years ago. Like, yes, it is going forever to the right. I get that it looks like it's going down, but it's also going right. What is the range?
It'd be -2, 1.
I will tell you that of all the things that you might mess up today, even though this is a kind of before you assignment, the most common mistake I'm going to see on this is someone's going to fall for what Zane fell for, and they're going to say, "Ooh, this dot represents the lowest point." So I'm going to say, "Ooh, the range goes from -2 up to its highest y value at 1." And I just want to tell you, don't fall for that, right? What is the lowest point on this graph? Negative infinity. So you're going to see a couple times I kind of planted a couple. I change this assignment every year. I add extra arrows and circles and stuff. But the bottom line is don't fall for it, right? What you might think is a low point is actually just an insignificant point in the range scheme of things. So we would say that the range actually goes from negative infinity, and its highest point, we do agree, vertically speaking, is 1. That's the apex of the graph. So that y value is the top. So that's what you're going to do after the quiz. You're going to just knock that assignment out. It's a great thing to do today. Perfect time. You should have no troubles. Get it done. And then tomorrow, God, 26 minutes. I don't know what we're going to do. I wouldn't expect anything groundbreaking tomorrow. Tomorrow's going to be a bit of an odd day here at Burns, right? How many of you guys are going to be gone for band already? Just one? And then are you cross country? Uh, football guys are probably already long since gone.
We get up at 10 a.m.
Oh, Jesus. So listen, don't expect much tomorrow. There's not going to be a lot of meat on whatever bone there is. But today, let's do our best on the quiz. And then let's knock out this assignment 5, I think it is. Hey, before we take the quiz, do you have any questions about complex numbers, distance, midpoint, graph? All right, let's do this. Let's get this done. Move your booty. Get out of the don't. By the way, I taped the floor. Did you see?
Yeah.
Yeah, I did different colors because with this many desks, they actually almost start to look. You can't almost tell like if they're side by side which two are the front of the desk. So I used different colors so that you could really see where the desks go. Remember not to put your desks on the tape, but rather just right behind so you don't book up the tape. There is an 84.1% chance you're gonna have me graded and back by tomorrow. I'm leaving myself 15.1% wiggle room because I got a lot of stuff. Trying to buy a house and another one. So I'll do my best, but don't know. No puede estar esto. Now you know that I need you to go purchase $12 job and nothing fancy, right?
Hey, text message.
You're gonna have to my class though. College for those. Miss Blocker, thanks guys, we should come in.